I'll be presenting on supervised learning and the issues associated with it. Supervised learning is one of the most widely used techniques in machine learning and artificial intelligence. It enables computers to learn patterns from labeled data and make predictions on new unseen data. In this presentation, I will explain what supervised learning is, how it works, its main types and applications, and also discuss some more common challenges and limitations faced when using supervised learning models. Machine learning is a branch of artificial intelligence that allows computers to learn from data and improve their performance over time without being explicitly programmed. Instead of writing detailed rules, we provide data to algorithms so they can identify patterns and relationships. Machine learning is generally divided into three major types: supervised learning, unsupervised learning, and reinforcement learning. Among these, supervised learning is the most commonly used because it works with labeled datasets where the correct answers are already known. Supervised learning is a machine learning approach where the model is trained using a dataset that includes both input data and the correct output labels. The goal of the algorithm is to learn a mapping between the inputs and outputs so it can predict the correct output for new data. For example, in an email spam detection system, the model is trained with emails labeled as spam or not spam, and after training, it can classify new emails automatically. The supervised learning process typically follows several steps. First, a labeled dataset is collected, then the data is split into training data and testing data. The training data is used to teach the algorithm the relationship between inputs and outputs. After the model is trained, it is evaluated using the testing dataset to measure its accuracy. Finally, the trained model can be used to make predictions on the new data. There are two main types of supervised learning: classification and regression. Classification is used when the output variable is a category or a class label. For example, identifying whether an email is spam or not. Regression is used when the output is a continuous numerical value, such as predicting house prices, stock prices, or temperature. The choice between classification and regression depends on the type of problem being solved. Several algorithms are commonly used in supervised learning. Linear regression is used for predicting continuous values. Logistic regression is used for classification problems. Decision trees create models based on decision rules. Random forests improve accuracy by combining multiple decision trees. SVM are effective for high-dimensional data, while k-nearest neighbors classifies data based on similarities. Neural networks are powerful models used for complex tasks like image and speech recognition.
So our next topic would be applications of supervised learning. What we are going to discuss about and see is supervised learning is generally a widely used application, and it's mainly used in healthcare to help diagnose disease. In finance, it's used for fraud detection and credit scoring. It's also commonly used in email services for spam filtering. Image recognition systems are also used in supervised learning to identify objects or faces in images. Recommendation systems used by Netflix, Amazon also rely on supervised learning techniques to predict user preferences. The next thing we are moving on to is issues in supervised learning, which is generally overfitting and underfitting. Despite its advantages, supervised learning generalizes several challenges. One major issue of supervised learning is that it requires large amounts of labeled data, which can be expensive and time consuming to collect. Another problem is also overfitting, where the model learns the data too well, but it fails to generalize new data. Data bias, data noisy, and computational calls are also important issues that can affect the model. Next thing you see is underfitting. Underfitting occurs when the model is too simple and cannot capture the relationship accuracy on training data between input and output variables. The ideal model should achieve a balance between these two situations. Techniques such as cross-validation, regularization, and increasing training data can help reduce these problems. Next will be data challenges. Supervised learning models strongly depend on the quality of data. If the data contains any missing values or incorrect labels or noisy data, the model generally fails to produce correct, accurate predictions. Another issue with it is imbalanced data set, where one class appears much more frequently than other. For example, in fraud detection, they generally data sets the fraudulent transactions which are very less compared to normal transactions. So this causes issues. Proper data pre-processing and balancing techniques are necessary to solve issues like this. So finally, to conclude on supervised learning, it's one of the most widely used techniques in machine learning. It allows computers to learn from labeled data sets and make accurate predictions in many real-world applications. However, it still faces challenges such as data labeling, overfitting, bias, and data quality, which need to be addressed carefully. By using proper data processing, model selection, and evaluation methods, we can build a much more reliable and efficient supervised learning system. This is all for our topic. Thank you.